Thanks, everyone. Very happy to be here and debut some new work that I've been doing with Julie Shaw, who leads MIT's Interactive Robotics Group, and we co-lead the Work of the Future initiative here. And that work, the short title of that project is Positive Sum Automation. I want to give you a sense of what we mean by that. So let me just give you a bit of the typical narrative around industrial automation. I'm going to focus in the beginning on manufacturing, but some of the same principles apply in healthcare, finance, and other industries. But here is some stills from a YouTube video that captures 1990s automation at GM. And as some of you might know, GM executives visited Toyota factories in the 1980s, and they thought the reason why Toyota was beating them on productivity was the robots that were in their factories. So they made this dedicated effort that they were going to have a lights-out factory at GM. This was part of that initial effort, the lights-out factory, where you don't really see any humans around on this line, this assembly line, just a lot of robotic arms that are caged and separate from the humans around them. So the auto industry adopted this type of automation en masse across companies. You see a ton of automation in welding, painting, assembly today in auto. And the next phase of that automation looks a little different, a little lighter, maybe a little more computing intensive. And this is stills from a Siemens video, where you see kind of the PLCs. You see some folks who look maybe more like software engineers versus UAW members. And the quote that's kind of the key to this video, which is from almost a decade ago now, is that we're looking, instead of high throughput, very repetitive automation like in the automotive industry, instead we're looking for highly flexible, individualized, resource-friendly mass production, which they demonstrate in this video by filling plastic bottles in different configurations. So this is all well and good, but as some of you might guess, well, what are the consequences of this automation? A lot of the headlines suggest that if we make progress in either the GM version of automation or in the Siemens version of automation, we're gonna experience a lot of job displacement. So headlines oftentimes read kind of scary about all these jobs that are vulnerable to automation due to companies' investments in new capital equipment. So this is where I think the typical version of automation ends. And you might be thinking, zero-sum automation is something like, well, companies gain, they become more profitable, more productive, even more flexible, and then the consequence is that workers get displaced and are less valued, right? So that's the typical story of zero-sum automation. It's a story that I don't subscribe to. I don't think this is accurate, hardly at all, in part because these headlines are pretty just wrong empirically, right? We don't actually see automation displacing workers. In fact, across studies, you could see the Netherlands. You have a study from France in here. This is work from our colleagues here at MIT that don't really show any relationship between the adoption of robots and job displacement at all. In fact, it's the opposite, that among firms that invest in automation equipment, like robots or advanced software, they end up hiring more people and becoming more competitive. So this story doesn't really compute that there's some benefit for the firm of automation, but a difficulty for workers. In fact, it seems to be beneficial for the firm in a lot of ways in terms of exporting more goods, gaining new product lines, also hiring more people. The wage question is still open. Some firms end up raising their wages overall, others reduce their wages. I'll talk about that in a moment. But the story is just not as clear as good for firms, bad for workers. The story is actually a little bit different. And the story that we try to expand on is that automation is actually really hard, and it hasn't penetrated enough firms. So you see the benefits in the studies of robot adoption, but in fact, in the US, and it's actually present across many OECD countries, that only 10% of firms in manufacturing have any robots at all. And then you look at other kind of software applications that might enable the Siemens type of automation, and there just aren't the software capabilities on the capital equipment side or on the skill side, because when manufacturing companies are hiring workers, less than 1 in 5 of those workers, they're required to have any digital skills at all. And that means like digital skills, very, very basic digital skills, like knowing how to run tables in Excel, for example. So this is not just a survey problem. This is data from the International Federation of Robotics that just shows flat robot adoption across Germany, Japan, Korea, and the United States over the last 10 years. You might think that in 2020, these numbers would have gone up, given labor shortages and difficulties in COVID. In fact, anecdotally, a lot of firms were exploring automation in COVID, but robot adoption went down. There's a little bit of uptick after. You can see the only real movement here is through robot adoption in China, where robot purchases have skyrocketed. Say more about that in a second. And then one of the other issues, if you're thinking maybe this is just a robot problem, there's a lot of other types of automation and productivity gains in technology other than robots. I'll refer you to this chart where between 1950 and the 1980s, you see this positive sum gain where wages, this purple line, employment, this kind of mustard colored line, they're all growing along with capital expenditures, productivity, and value added. But CapEx and value added manufacturing, flat for the last 20 years. So, and I can give you more, this is the really, I think, fascinating curve of today, which is you see job openings going up, right? This real concern about a labor shortage, spiking during COVID, but wages being mostly flat and not really responding to job openings. So the problem, I think, is summarized pretty succinctly by a person we've worked with in Ohio who owns a factory that's been struggling to adapt to the job shortage. He says, we have all this demand in the post-COVID world. We can't find workers to meet it. We know that we need to offer more than our $20 an hour to production workers to compete with the likes of Amazon and even retail, but we can't offer higher wages unless we automate. And the funny thing about this company is that several years ago, they bought a collaborative robot, a universal robot, to try to compete. And they thought that they would deploy universal robot arms across their multiple machines so they could essentially add a new shift, that their skilled machinists would go home and they would have their universal robot arms automatically loading these machines to continue on with the jobs during the evening. And they could monitor this remotely with software. But the problem was, for multiple years, their universal robot, whom they named Jeff, wasn't getting any work. Jeff was just kind of sitting in the corner because they didn't have anyone with the skills to program and reprogram Jeff for new jobs or integrate Jeff. They had hired a consultant to come in and program Jeff for the first job, but they couldn't get back in after that first job. So this helps explain a little bit why robot adoption and automation is challenging in small firms, but we also see it in big firms. You might have read about Tesla's attempt to, there we go. Tesla's attempt to automate a Model 3 factory, and then the Model 3s were delayed. The different automated lines within the factory frequently broke, and I think, again, succinctly, the Tesla CEO, humans are underrated. In China, there have been extensive incentives from the federal government for manufacturers, particularly in electronics, to adopt robots for assembly. But when the Harvard sociologist Yao Wenlei studied through interviews in these factories and looked to see if these robots were actually being used, she found they weren't being used in the ways they were intended. Instead, the firms were acquiring them to get the subsidies and then not using them for assembly. I know you can read this. I'll read it for the benefits of those in the rooms. We've tried to make robots assemble components, but robots often break delicate and expensive components. From the process, I've realized that the human body is magic. So a lot of the perceived upside of robotic automation and production automation in these cases were not realized. And then finally, from the interviews of some of our colleagues here who worked on the Work of the Future project, we revisit this idea of a lights-out factory, a fully automated system without any human in the loop. And one, I think, cheeky manufacturing business owner said he didn't want a lights-out factory because humans were key, even in an automated system, to that system's ability to innovate. Okay, now a lot of our work, takes a lot of the challenges of automation and the low technology adoption as a given, and then asks how do we overcome whatever barriers there might be to technology adoption. And what we've identified as these barriers through interviews with firms, factory visits, and some of this work with data is that the technologies that are currently available for automation, they're very sensitive to changes in the external environment, that they can't really adapt to new, let's say, a new factory context or a new work context or a new product that might be developed. And it takes a lot of skills if you want to switch between applications. And then finally, these systems are oftentimes in a black box such that the workers who interact with them most might not actually be able to tweak them or understand how they can use them for innovative purposes that the business might need. Now, what we mean by positive sub-automation and overcoming these barriers is that we want applications, technology applications, they deliver productivity gains, like the GM factory is experiencing with a high throughput, highly repetitive automated system, while also improving flexibility, the ability to switch between products, the ability to add to innovation, and adapt as the business grows and changes. So here's our kind of three-pronged approach that's multidisciplinary. It brings in kind of the social science and management dimensions, which I work on, as well as the technology design dimensions that my colleague Julie Shaw works on. So I'm going to go through each of these one by one. But really, we think that there's a component for engineering here, which is how do you design systems that are more flexible, that might sacrifice a bit of the productivity gains that previous very fast, high throughput systems have achieved, but also gain flexibility. So you might have to sacrifice a little productivity, but you're going to gain lower switching costs as a result. Finally, there's a key. The integrators are key. So who sets up this equipment and has the skills to use it? And then finally, there is the issue of measuring the success. So I'm going to go a few examples here. So the first example is a design problem that we've encountered. So even with robots that are called collaborative that you might find, and if some of you work in this industry, there's a difference between the classic industrial robot, which is fenced off from the workforce, and the collaborative robot who, I shouldn't say who, that would personify the machine, but that can be next to a worker, and there are additional safety precautions. But the collaborative robot in practice hasn't collaborated as if handing off a part to a worker very successfully. Instead, it can coexist safely. It hasn't gotten to the point of collaboration. And I'll give you one example from a factory that Julie's worked with. So the process that the robot's working on is assembling scientific equipment, so equipment that can be delicate and require a lot of precision. And the purpose of adding a collaborative robot arm was that there was this heavy assembly that the robot was going to lift so that the worker could then put in the relevant screws and sensors into the assembly to finish it, and then the robot could stack the assembly afterward. But when Julie visited the factory, the robot wasn't in use. That the production worker had ended up just doing this process on her own because the robot could only do one thing and wouldn't be able to adjust to the ergonomics of how the worker wanted to do the job. So she was able to customize it on her own. And what's more, she could also work faster than the robot anyway. So she didn't feel like there was an incentive to use the robot, and it wasn't as reliable for her to meet the metrics that she needed to meet. So that was a frustrating outcome. So the question there is, how could you make a robot that this production worker was comfortable training or adapting or tweaking to her own standards and could also keep up with the pace that she had come to expect? Second example, and I'll move out of manufacturing here for a moment to a healthcare example where robotic process automation, as some of you might know, has become very popular among administrative offices in general, but in healthcare, RPA has been used to take these very routine tasks that can take up a lot of an administrator's job and just create a bot that could click through in the same pattern that an administrator would click through. And a lot of these hospital systems, they face a choice initially when they're adapting RPA. They could try to pick from the C-level executives, pick the tasks in the areas that they want to automate and where they want to drive efficiency, so make big gains and big investments in these processes, or they can go from the bottom up and they can choose several lower level teams that can let ideas percolate and decide how they want to use these tools within their own domains. And the partner that we've worked with, the hospital system, started with a top-down approach where the process was driven by the CFO looking to essentially cut labor costs. There was a difficulty of filling all the positions that they needed to fill. They were growing really quickly, thought automation could take away some of, say avoid hiring as quickly as they were trying to hire. So they hired a consulting firm. The consulting firm came in and said, here are the tools that you can use. They picked out the software. They said, here's how you program the tools. And then the hospital system said, okay, we'll take it from here. And the we'll take it from here, I think, came from a few dimensions. One was the hospital system didn't want their workers to revolt. There were some rumblings that the workers didn't want the automation to be imposed upon them. They were worried about their job security. And in many ways, they thought they knew the best routine processes to automate rather than the C-level executives. So what the hospital system opted for was a more bottom-up approach, where these individual teams that were responsible for the routine tasks decided what to automate, and then individuals from those teams were trained in how to create these bots to automate their processes. Now, what you got were, and I interviewed many of these folks, very happy administrative teams that said they were able to avoid now the soul-sucking work of doing these administrative tasks, and they actually got to focus on the things they enjoyed most about their jobs. If you talk to the C-level executives, they were happy that this process had gone rather smoothly, that maintenance was easier because now you have people who know the routine processes and know how to program the bots, so you can update and adjust relatively quickly. But from the top-down perspective, there was still a lot to automate left on the table that you were never going to generate from the bottom up, because you just didn't have the level of view to take on big tasks and essentially big team-type routine processes. So now the same hospital system is looking toward using more sophisticated tools, more flexible tools, kind of AI-based algorithms, but they haven't really gotten there yet, even though they are overall a very sophisticated administrative system. That kind of speaks to the low technology adoption in large organizations as well. And then finally, probably my favorite example of how we get at this black box system challenge. There's a company in Ohio that has taught me a lot. It's about a 20-person firm, and it is heavily automated. And over the last, I would say, 5 to 7 years, they've added some type of automation to every piece of equipment in their shop. I was just at their shop last Friday. And what's remarkable compared to other crowded, 30-year-old factories that you might visit, this is a very crowded factory, but it's crowded because it has so much equipment, not because it has so many people. And the people are very happy, and they're working very independently. It's hard. I didn't give them a survey to assess their happiness or anything, but there was really a feeling of excitement. And one of the reasons is that they make double what their colleagues down the street do. Right? It's a minimum wage of $30 an hour, whereas in manufacturing, a typical entry-level worker will make anywhere from $15 to $17 an hour in a place like Ohio. So really dramatic increases at a firm like this. And how they got there was transforming their productivity, really almost, I think, tripling their revenue per worker over the last 7 years. So they did this by investing in robotic machine tending mostly, and just spending a ton on capital equipment such that they're growing out of their facility. And the way that they've combined this investment in capital equipment with their workforce is they've linked their bonuses and their training to all their investments in technology. So the technology's enabled them to measure the performance of each machine and each worker, even if they switch between machines. And they've said that they'll be able to measure, even if the worker brings new ideas to the factory, how much time that they've saved through those new ideas, and that's linked to their bonus at the end of the year, on top of the $30 minimum wage. So they have quite a few folks. These are workers primarily with high school degrees, maybe some vocational training, making closer to 100K now in Ohio. So where does all this leave us? It leaves us with a slightly different idea of how to conceptualize robotic automation, automation software as part of a firm. So traditionally, and going back to this image of GM and what GM learned from Toyota, the takeaway from the GM perspective was that machines can be more productive than workers in certain contexts. In highly repetitive settings with high throughput, we can train a machine, we can program a machine to be more reliable and faster than a worker. And how we can measure the benefits of that machine is to look at its productivity compared to the productivity of our human workers. And we realize is that in some cases this is just true, right? This is how a lot of companies think about RPA. They try to measure the time that a bot can do the work versus the time and money that a human can do the work, even with the various quality issues that might arise. But there's also a different way of looking at automation that gets you the productivity, some of the productivity that might happen in these high throughput situations, along with more flexibility. And that's thinking about robots and software as tools that can help teams become better at tasks, not just doing the highly predictable tasks, but also adjusting as the team, mostly the humans on the team, are figuring out better ways to solve the problems and perform them. And I should note, this is the last slide, and I think we have 10 minutes left, that this is part of an ongoing project. Some of this work is going to be published early in the new year, but it's really more about we're beginning to learn about these challenges of technology adoption through what we're calling our automation clinic, where we work with firms. We go out, conduct factory visits, office visits, do interviews, and learn from people like I'm sure many of you who are puzzling through a lot of these challenges and realize that they're much more difficult than the promotional videos from technology providers lead you to believe. So we're trying to tap into those real stories. We're bringing PhD students from MIT and others onto the factory floor to see how technology works in practice. And if any of you are interested or would be willing to invite us to come pay you a visit and ask you a bunch of questions, I'd love to follow up. So, and if there are any questions, I'm happy to answer them here as well.
Thank you. Questions on the Pigeonhole. Ben, you can look at the questions over there.
Oh yeah, great. Yeah. Now a few. I saw the one. Okay. Yeah. So a question particularly about platforms from large software providers to help address some of these challenges. The one thing that is a consistent challenge, and this is more for smaller firms than larger firms like BMW, is that the process of technology adoption isn't like you'll wipe out all of your technology suite and then adopt, let's say, all Salesforce or all, even in healthcare, right? There are certain hospital systems that adopt Epic, but they still need this constellation of other programs around it. And one of the challenges for automation is, yeah, Quan? Oh, sorry about that. I'm forgetting about the folks. The question is, to what extent will NVIDIA's Omniverse platform initiative help to address some of these challenges? For example, BMW's factory transformation with Omniverse. So I'm trying to speak beyond just the NVIDIA case, but also to other large firms. And one of the issues here is the compatibility of different technologies within the firms, and that automation can exist within one system, but it needs to kind of be able to stitch together the one system with another. And this is one of the challenges that I think robotics firms and robotics integrators have found, is that even if you can program the robot, you can't necessarily program the task that the robot needs to perform, which relies on multiple different technology suites oftentimes. Can we go back to the other questions?
Yep. Get to the list of questions.
Okay.
Any advice?
So, any advice for companies to automate old legacy factories in more economical ways? Yeah, so legacy factories, there was last Monday I was at a factory actually in Massachusetts that I found very impressive that performs a legacy task. They've been around for, I believe, 40 years. And it's a somewhat simpler case because there's, I would say, a high variety of products, but they don't vary that much. So they're able to use the same line to produce products with slightly different dimensions. And what they've done that's very interesting is they use mostly custom machinery, but although they need to change and upgrade their machinery a lot of times, they've built their whole platform around Salesforce. And they've been so committed to having a single software thread from the front office to the back office that they've avoided what you might think of as tempting productivity gains by using other more, I think, manufacturing-friendly softwares, but they've seen huge gains for that. So I think that having a consistent software platform while you're bringing in new equipment, other firms have used consistent machine interfaces, even if they're bringing in different types of machines that I think could be beneficial. I've seen companies say it's beneficial. All right, what do you see as the most promising emerging technology and innovations to increase robotics adoption? I do think there's a lot of potential in collaborative robots, and I think one of the big missing pieces is the cost of integration and the ease of reprogramming, not just initially programming, but reprogramming. So one of the challenges in kind of the machine tending application, just for background of those outside this space, three main applications for robots, particularly collaborative ones. There's assembly, there's materials handling, so like picking and dropping, particularly on assembly line, and there's machine tending, loading and unloading machines and then stacking finished parts. In the machine tending example, I think there's a lot of room to make it easier to make small adjustments versus feeling like the robot's locked in. So lowering those switching costs between one product and another is really, I think, an important design feature that I know a lot of folks are working on.
Ben, I also have a question, if you don't mind.
Please.
Leveraging my role here.
Yeah.
Would you mind to say something about the future, the work of the future, MIT work of the future initiative you and Professor Julie Shah are leading?
Yes, so a lot of what we're focused on in the Work of the Future initiative grows out of this Work of the Future task force that began in 2018, and I gave the kind of the headline of the New York Times article that summarized the task force's work, which suggests that the quantity of jobs is not threatened by new technology, but the quality of jobs is dependent on how new technologies are developed. So one of the big challenges that we see in our research and teaching is trying to understand how technology design decisions and organizational strategies might affect the quality of jobs in a more advanced technological environment. Okay, so I'll go back to these. Yeah. Aren't many issues mentioned in the talk could be solved by better robots? Sure, a lot of them. Yeah, I think that there's the issue of better robots, but it's not, you could have far better robots without the workforce to actually operate them and adjust them. So one of the big challenges, like if I were to focus on one number, one challenge from the slides here today, it would be the 18% of manufacturing job openings that require any digital skills at all. I mean, the real crisis, job shortage in manufacturing, but also in other industries like logistics, with a few companies accepted, is software, right? There's just not software skills in manufacturing, such that when you try to do something sophisticated with software, for a lot of manufacturing companies, you have to bring in external talent that doesn't really know the manufacturing side of the business. So I think it's easy as it's the Ballmer developers in the manufacturing context, which just hasn't really caught on despite 10 years of talking about Industry 4.0.
He's having another 10 minutes. Should we continue?
Yeah, how could robotics and automation work together with the concept of digital twin in manufacturing? Yeah, I think the concept of a digital twin, or digital thread through the product development and production process is important, and a lot of there's a great researcher and entrepreneur at MIT named Bruce Lawler. I'm not sure, he might be even talking today since this is his topic, who works on essentially this question: is how do you automate kind of the front office as well as the engineering side of manufacturing in addition to the production process. And he runs a group here called MIMO that if whoever is interested in this question might check out. And right now they're looking at machine learning applications for manufacturing.
Lots of questions.
What are the guiding principles for designing robots and manufacturing processes to be added value for teams versus replacing teams? Yeah, so I think that there's the two guiding principles that we're focused on in our work right now are accessibility is number one. So that's like the low code intuitive systems. So the accessibility of training and retraining the machines. And then the second piece is not necessarily a design principle, but more of an organizational principle of trying to do bottom-up integration, so that it's not an external party that might not know your business very well that comes in and integrates and is responsible for A, setting up, and B, repairing the system, but there needs to be some internal buy-in and internal expertise that can understand how to best appropriate the system. Okay, can you please expand on your bottom-up deployment example? How was it introduced? How ownership was distributed? Challenges overcome, et cetera? So the bottom-up deployment example, I can't share the hospital system name, but when we publish this, we're going to be able to share the hospital name. So yeah, so how is it introduced? The story goes, if you're interested, there was a discussion at a board meeting at the hospital that by an engineer who said, how do you plan to use the benefits of the advances in artificial intelligence to make the hospital more efficient? And the CFO heard that and said, I don't know, can you help? Can you help us figure this out? So in figuring this out, what they realized was that maybe they wouldn't be able to use the most advanced, the latest and greatest in artificial intelligence, but what they could use were more like a decade and a half old advances in robotic process automation that could bring them further than they had been so far. So that led to the hiring of the consulting firm, like I mentioned. In other cases, what I've seen in bottom-up deployment in manufacturing is that when a manufacturing company is bringing on new technology, what they'll do is, they'll send, right as they make the purchase, they'll send several of their production leaders whom they trust to go get trained on the system, and this is from the bottom up, the people who are being trained. And they'll also, if they're developing new software or buying new software, they'll get advice on what types of applications they should have for the software from people who are working on the line and who are working with the interface directly. So this is, I think, for those who might have UX training in the audience, this is pretty basic, user research. But the users in these cases are, production workers with a high school diploma and might have some different needs and different ideas than the engineers who develop the software. Yeah, so does the term positive sum automation imply that the whole human-machine team is greater than the sum of its parts, or is there another meaning to the term? So I like this suggestion of the meaning of the term. It's not quite what we mean, but I do think that's correct. And one of the ways that we think we should be measuring the benefits of automation is how teams perform with automation versus how teams, the counterfactual of how teams have performed without automation versus just how does the machine perform versus how does a human worker perform. What we really mean by positive sum automation is that there's traditionally been this trade-off where you gain productivity but you lose flexibility in a high throughput production process. But we're working toward technologies that get you both, but maybe less productivity, but certainly more flexibility. Many SMEs operate with low margins and struggle to fund investments in automation. How can this issue be resolved? Great question. I work a lot on this, and I talk to a lot of frustrated SMEs about this. So I would say the SMEs I work with operate with variable margins. So let's say you have a mix. So the background statistic that we should use is that about 40% of SMEs in New England, this also applies to Ohio and other places, have at least one defense contract. So our industrial base in the United States, small, medium manufacturers, is hugely dependent on the military and on military contracts, which are typically higher margin. And some of these firms have used their military higher margin contracts to fund investments in new equipment. So they've tried to find the strategic contracts that would allow them to then use their funding to support the purchase of a new machine that could then lead them to bid for other business. Struggle to fund investments in automation. The capital markets for automation are pretty terrible, right? The banks don't want to fund this. They kind of have the quotas for how much they want to spend on capital for manufacturing firms. There has been a private equity market for some manufacturing investments, but family-owned SMEs don't really want to go there. So the best case right now that we've seen is from defense contracts. There's another case that I find interesting where it's a buyer-supplier relationship. So I know there's a lot of global presence for ILP, and the relationship between the customer and the supplier in places like Germany and Japan works so different, where if a supplier really needs a new piece of equipment to meet certain quality standards or a new product coming from their OEM, that the OEM might finance that equipment purchase, and then the supplier will be able to pay it back over time. That's not a typical arrangement in the US that I think could be beneficial, but the supplier-buyer relationships here just aren't as durable and as trust-based as in other places. Okay, can you speak of advances in collaborative robots by major robotic manufacturers? Boston Robotics, Boston Dynamics maybe? Yeah, so we do some work with robotics manufacturers and talk to them about challenges, not really, let's say, advances on the technical side as much as or let's say the sophistication of the gripper or the speed of being able to move around safely. That's not really my expertise. It's more around these integration and workforce questions. So I'm sorry, I just don't think I can answer this effectively. How much are the firms you interview aware of advanced technologies, and what's their main concern in implementing them? what do we need to overcome this? Yeah, there's clearly not one answer. So I would say there is general awareness. So firms might see these technologies at trade shows, or when they talk to their peers, they might see peers experimenting with these technologies. One of the interesting dynamics that I've seen is that there are peer groups of firms with similar technology constellations. So the firms with robots typically know and talk to the firms with robots at that 10%, and then the firms without the advanced technology are maybe more associated with one another. I don't think awareness of the technologies in general is the problem, but the question is what can this technology do for me? And one of the real benefits of a technology like additive manufacturing is that firms can make a pretty low-cost purchase to just try to figure it out for prototyping, and it's not very consequential. Firm doesn't feel bad if they're not using it all the time. Whereas the purchase of a robotic arm, which is not a collaborative robot, isn't that much more expensive than a industrial piece of 3D printing equipment. But it's much harder to figure out how to use in a low-cost. What's the entry point for robotic automation? And that's one of the challenges that we're trying to figure out in a more playful way. Julie Shaw, my collaborator, has an exhibit in the MIT Museum, for those of you visiting, if you want to check it out, where her lab has trained has a robot set up to make sandwiches. And the idea is that you in the museum can go and train the robot to make a sandwich the way you want, or to set the table the way you want. And that hopefully, not an industrial application certainly, will help make the training and retraining process seem more accessible and introduce people to the capabilities of the equipment. All right.
Thank you very much.
Thanks so much. Appreciate it.